because I. So cos 0. Cos 0 value how much?
1.
So therefore I dot I is 1. Similarly, j dot j is also 1. K dot k is also 1. So if you consider I dot j, that will be 90. Cos 90 will be 0. So we will get 0. So therefore I dot I, j dot j, k dot k is 1 and remaining combinations will be 0. So this is dot product. Second one, cross product. Cross product. If vector product of two vectors is also a vector, that is called as cross product. The vector product of two vectors is also a vector. Consider two vectors, that is a and a bar and b bar, that is vector a and vector b. Now the product of these two is also a vector, that is, let us consider a vector c equals to what? Vector a cross b. And usually this can be written as vector a cross b equals to, that is, ab sine theta, and this is also in vector form only, so that's why we can substitute into n. So n cap, where n cap is a unit vector, represents the direction of the resultant vector. Actually, in this chapter, this cross product is very important part, so listen carefully. And here, the resultant vector having in the resultant vector is also having the direction, no? Because that is also a vector. Then what is that direction? What is that direction? See here, for example, so to find the direction, we are using right and thumb, right and thumb rule.
Sir,
So
you have done
consider
this
right hand
chapter, no, sir?
and keep. Huh? What?
You have done this chapter.
Yeah, I have done already, but it is chapter also. Okay, so that is just I am revising.
Rotational.
In rotational motion. So this chapter will come. This concept, that is only cross product, will come. So that's why just I am revising that.
Okay, sir.
So the resultant vector having the direction. So consider the right hand, and if you keep four fingers like this, one vector, say vector A, and if you fold this one, this is vector B, and the cross product of vector A and vector B, resultant will be this one. So this is the result. Suppose if we keep along x-axis is a vector A and y-axis is vector B, and resultant vector will be z-axis, like that. Okay. For finding the direction, we are using right hand thumb rule, or also we are using screw rule. Screw rule. And unit vectors, if we consider, so unit vectors. That is I cap, j cap, k cap. So unit vectors will be so cross product. If we consider here, I cross j equals to, that is I cross j. So I cross j equals to k cap. I cross j equals to k cap. And j cross k equals to what? I. So j cross k equals to I cap. That no resultant. If your fingers, if you keep along x-axis and y-axis, then the result will be z-axis, no? Like this only. Similarly, so k cross I equals to j cap. So, and if we change the direction, suppose if we consider from y to x, from y to x, the fingers, four fingers, if you arrange in the direction of from y to x, then the direction will be opposite. along z axis only, but it is opposite. So and also j cross I equals minus k, and k cross j equals to minus I, and I cross k equals to minus j. So this is a cross product, and remaining all other combinations you will get 0. Remaining all other combinations you will get 0. That is remaining only one combination, that is I dot I cross I, j cross j, and k cross k, k cross k equals to 0 because theta is 0, that's why. So this is the cross product. And if we consider two vectors, how to solve these cross product means? So here only we can find the magnitude, that is vector E. This is the vector A, and so consider vector B, dxi cap plus dy cap plus bz k cap. So A cross B will be A cross B. By using matrix method, we are finding the A cross B determinant method. So that equals to what? I, J, K, and so plus minus plus. So A cross B are doing, that's why first we are writing A variables, Ax, Ay, and Y variables. So Bx, By, Bz. So we are doing, we already explained this one, I cap into. So this row and column we have to eliminate. First I consider I, no. So therefore the that you can remove it. So if you remove I into, see, I into, so this row and column I will remove it. Then what you'll, what it left? Y into bz, ay az by bz. So this formula is what? Ad minus bc. Ad minus bc. So according to that, if we consider, finally you will get I into ay bz minus az by.
BZ.
Similarly, minus j into row and column if you remove x, that is
X,
ax
AZ,
bz
BZ.
minus az
BZ.
by plus k into
AX,
ax by
BX, AY, BZ, BY.
ay bx. Like this we are doing. So this vector you will get, then you can find the magnitude. That is the same like this ax square, ay square, az square and all. So this is the cross product. Understood? Finished? Understood? So I go for next one.
Yes, sir.
Yes.
1 minute.
Had food, all of you.
Yes, sir.
Yes, sir.
Done, sir.
Right. Anish, finished, huh? Right.
Sir.
Next one is, so that is rotator motion only. Few relations we will discuss. So see, circular motion and rotated motion both will come for circular motion. See, suppose an object is moving in a circular path. Array, I'm not able to draw in circle. So this is one circle. If particle is rotating in a circular orbit, then so what are the things will come? Let's discuss and their relations and all. So do you know what is angular displacement?
Yes, sir.
The thing both. Correct रहता? Right. So its radius is, let us consider its radius is r. Its radius is r. Now suppose the particle is at point A. Now it is moving in circular motion. So therefore after some time the particle is reached to point B. So and radius remains same and it makes an angle theta. So this theta, small line theta. And what is the distance? So let us consider this L, arc length, we call it as arc length. So here displacement we know. What is the displacement? Linear displacement. Displacement. Shortest
Change in
distance
position
between
with
2 points.
respect to time.
So here we know that. So arc length equals to what? Arc length. You know the formula. Arc length. So L equals to
R.
R into theta. Do you remember? So L equals to R into theta. And suppose this is a small angle instead of total angle, if we consider a small angle. So and this length is also a small length. So this will be d theta, a small displacement, angular displacement, and small linear displacement dl. So therefore dl equals to what? R into d theta. R into d theta. D theta. This is a relation between linear displacement and angular displacement. That is dl equals to so r into d theta. Right? So this is equation 1. Remember here. Now next one is angular velocity. So angular velocity. What is the angular velocity? The rate of change of
Displacement.
change of angular
Angular
displacement.
displacement.
Angular displacement. So that angular velocity represented with omega. So omega equals to rate of change of, that is d theta by dt. D theta by dt. So this is the angular displacement. And what are the units for? So units. So SI
Per second.
units are what?
per second.
Radians per
per
second.
second. Radians per second. SI units are radians per second. Radians you will understand if I write like this. Usually we are writing like this only, radians, READ, per second.
Yes, sir.
It's angular displacement. What is the relation between angular displacement and linear velocity? Sorry, linear velocity and angular velocity. So relation between linear velocity and angular velocity.
Angular velocity into radius is equal to linear velocity.
So from this, see, dl equals to what? R into d theta. So differentiate with respect to t. If you differentiate, then this will be what? dl by dt equals to R into d theta by dt. So from this equation, see, dl by dt. dl is what? Linear displacement. So linear displacement by time is nothing but a linear velocity, R into d theta by dt equals to what? Angular velocity. So that equals to v equals to what? R.
Sir, what is direction of angular velocity?
That one I will tell you. So, but all are vector only. R, V, and everything is vector. So therefore, if we consider linear velocity, v equals to in terms of what? It is R vector cross omega, or omega vector cross. Right? So by using right hand thumb rule, we are finding the direction part. So here see, this is linear velocity and this is R vector, R. And from this, one is like this, other one is tangential, other one is radius vector. These two are perpendicular to each other. Then what about third one? So third one is, it will be outside or inside the plane of the paper. That is outside the board or inside the board. So by using right hand thumb rule, we are finding the directions. So usually omega, angular velocity, will be along the z-axis. Remember, along z-axis. It may be positive z-axis or negative z-axis, depending upon the object rotating in a circular path. Understood?
Yes, sir.
Understood?
Yes, sir.
Right, next one. Next, angular acceleration. Angular acceleration.
Sir, radians has no dimensions, no?
No. That is a plane angle. Radians and solid plane angle. So plane angle doesn't have any radians. Yes, so here only I will show you. See, we have written on that is dl equals to what? R into d theta.
Yes, sir.
Also R equals to L equals to R into theta. Theta equals to what? L by R.
Yes, sir.
L is also meter, so R is also meter. Meter get cancelled. Therefore, there is no dimension.
Okay, sir.
But SI units they have provided, that is radians.
Okay, sir.
Okay. Angular acceleration. So angular acceleration represented with alpha. Alpha equals to. So what is that one? That is rate of change of angular velocity. So rate of change of angular velocity is angular acceleration. What are the SI units?
Radians
Generally
per
acceleration,
second
what are the
square.
SI units? Meter per second square. Huh?
Yes, sir.
So here meter instead of meter you will get radians. Radians per second
Second
square.
square.
And what is the relation between linear acceleration and relation between and angular acceleration? Okay. So if you consider here, so we already know what is the relation between velocity and time. So see, dl equals to r into d theta. So from this you will get v equals to what? R omega u got a r omega. So again differentiate this with respect to, so differentiate with respect to t. So differentiate with respect to t. So if you differentiate with respect to t, then this will be what? D by d equals to r into, so d by dt of omega, dv by dt. So what is dv by dt? Rate of change of linear velocity will be what? Rate of change of linear velocity. That is what? Acceleration A. So and here rate of change of angular velocity will be alpha. That is A equals to r alpha. And here in vector form if you write, so that is r plus alpha. This is the relation between angular acceleration and linear acceleration. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
Yes, sir.
So kinematic equations we know. So that is
So once again, can I show the previous slide?
previous slide.
1 minute, sir. Let me write the.
Right.
Okay.
Someone asked for previous page.
Yes, sir.
One minute, huh? It takes some time.
Yes, sir. Done, sir. Thanks.
Finished, huh?
Yes, sir. Done.
So kinematic equations we know in linear motion. Tell me those equations once.
V is equal
V
to U
is
plus
equal to U
18.
plus 80. V square is equal to U square minus
Plus 2s.
S is equal to UT plus half AT square.
Hmm.
2 into n.
N minus 1 now. Yes.
Yes, sir.
So in rotation motion, you tell me now. Rotational motion. B is nothing but a final velocity. We are writing omega.
Omega is equal to
Initial velocity.
omega naught
Omega naught plus A is nothing but
alpha
what?
alpha into t.
Alpha T.
Omega
Omega
square
square
minus
minus omega naught square is equal to 2 alpha theta.
theta
Theta
equals
is equal to omega naught into t plus half into alpha t square. Theta n is equal Sn is equal to omega naught plus alpha into n minus
the kinematic
Sir, for
distance in case of a rotate.
nothing sir.
Understood?
Yes sir.
ಮತ್ತೆ ಇನ್ನೊಂದು ಯಾವ್ದೊಂದು ಕ್ಲಾಸ್ ಆಯ್ತಾ ನಿಮ್ಗೆ?
ಇಲ್ಲ sir.
No, sir.
ಇದೇ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್?
Yes sir.
Yes, sir.
ಸರಿ ಹಂಗಾರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ.
Sir, ಎಂಟ
ಕ್ಲಾಸ್
Tomorrow
Huh?
Republic Day, sir.
Yes sir.
Tomorrow Republic Day, sir.
ಇವತ್ತೇ ಇನ್ half an hour ಇದೆ sir class.
ಸೊ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ ಅಂತ ಹಂಗಾರೆ.
Yes sir.
ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಒನ್
Can you show the previous page?
ಸೊ ಟಾರ್ಕ್.
ಸರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿಗೂ ನಂಗೆ ಡಿರೈವ್ ಮಾಡಿ ಸರ್.
Done, sir.
ಯಾವುದು?
ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ half mv square. Okay.
ಡಿರೈವ್ ಮಾಡ್ಬೇಕಾ?
ಬಟ್
ಅದ್ಯಾಕ್ ಬಂತೀಗ ನಿಮ್ ಡೌಟ್?
ಸುಮ್ಮನೆ ಕೇಳಿದೆ ಸರ್.
ಸುಮ್ನೆ ಕೇಳ್ದ ಟೈಮ್ ಪಾಸ್ಗೆ?
ಎಸ್ ಸರ್. ಬಟ್ ನೀವು ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿ ಇನ್ನೂ ಹೇಳ್ಕೊಟ್ಟಿಲ್ಲ ಅಲ್ವಾ ಸರ್?
ಇನ್ನು ಇಲ್ಲ, ಇನ್ನು ಬರ್ತದೆ.
ಓಕೆ.
ರೈಟ್. ಯಾಕೋ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕೇಳಿದೆ ನೋಡಪ್ಪ. ಇದು ಡೆರಿವೇಶನ್ ಮಾಡಿದ್ನಾ? ಇಲ್ಲಲ್ಲ.
ಯಾವುದು ಸರ್?
ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ
ಸರ್ ನೀವು ಇದ್ರ ಬಗ್ಗೆ ಇದರಲ್ಲಿ ಯಾವ್ದು ಕೈನೆಟಿಕ್ ಥಿಯರಿ ಆಫ್ ಗ್ಯಾಸಸ್ ಅದರಲ್ಲಿ ಟ್ರಾನ್ಸ್ಲೇಷನಲ್, ರೊಟೇಷನಲ್, ವೈಬ್ರೇಷನಲ್ ಮೋಡ್ ಆಫ್ ಎನರ್ಜಿ ಎಲ್ಲ ಮಾಡ್ತಿದ್ರಲ್ಲ, ಅದರಲ್ಲಿ ರೊಟೇಷನಲ್ ಮೋಡ್ ಆಫ್ ಎನರ್ಜಿಲಿ ಫಾರ್ಮುಲಾ ಬಂದಿತ್ತು.
ಏನ್ ಫಾರ್ಮುಲಾ?
3/2 I ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಅಂತ.
ಅವೆಲ್ಲ ಇವಾಗ ಬರ್ತಾವಿರೋ ಹಂಗಾರೆ ಇಲ್ಲ ಲೆಸನ್ ಬರ್ತಾವೆ. ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಜಿ ಡಿಸ್ಕಸ್ ಮಾಡಿಲ್ಲ.
ಎಸ್ ಸರ್.
ಸೊ ಒಂದೊಂದೇ ಡಿಸ್ಕಸ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ ಟಾರ್ಕ್. ಟಾರ್ಕ್ ಮೀನ್ಸ್ ವಾಟ್? ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಪ. ಸೊ ಕೇರ್ಫುಲ್ ಆಗಿ ಕೇಳಿರಿ. ಟಾರ್ಕ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಫೋರ್ಸ್ ಇಂಟು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್. ಎಷ್ಟು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬೇಕಂದ್ರೆ, ಇಮ್ಯಾಜಿನ್ ದ ಡೋರ್ ಐತಲ್ಲ, ಡೋರ್ ಕ್ಲೋಸ್ ಮಾಡೋದು, ಓಪನ್ ಮಾಡೋದು
Yes,
ಡೋರ್
sir.
ಐತಲ್ಲ
Yes, sir.
ಒಂದ್ ಎಂಡ್ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತೀವಿ, ವಿ ಹ್ಯಾವ್ ಫಿಕ್ಸ್ಡ್ ಅಟ್ ಒನ್ ಎಂಡ್ with the help of hinges, and other end, so we will fix lock, bolt to lock and all, right?
Yes, sir.
Latches and all,
Yes, sir.
everything we put. So handle also will be there. So, and in the entire length of the door, so if you apply the same amount of force at different places, so this is the door, okay, ಇದು door ಸರಿನಾ, ಇಲ್ಲೊಂಥರ
sir.
ಫಿಕ್ಸ್ ಮಾಡಿದೀವಿ ಅಂಡ್ ಇಲ್ಲೊಂಥರ ಫಿಕ್ಸ್ ಮಾಡಿದೀವಿ. So now if we apply the force on this one, so like this, if you apply force, then what happened, the door start rotating like this,
Yes,
Yes.
sir.
Yes, sir.
say you are applying the force F equals to 10 Newton, for example, and the distance, so the distance from hinges to where you are applying the force, so hinges to force, so this is the distance R, and exactly you are applying exactly perpendicular to the door, the force is perpendicular, means this is the angle, so angle, this is the angle is equals to how much, 90 here. Now see here, two cases, I will tell you in the two cases, the same force and always you're applying perpendicular at different points. At this point I'm applying, and at this point I'm applying, and at this point applying, okay, finally 4 points, first, second, third, fourth, with same force I'm applying. Out of all these force, which force will cause the door to rotate more?
Near
Which
the
force will
handle,
rotate the
near
door
the
more?
handle
Force
or
1.
lock.
Force 1, no?
Yes, sir.
At force 1. And even at force 2 also it will rotate, but more difficult as compared to first one, right?
Yes, sir.
Even further, if we consider third one, so at point third, it is still more difficult to rotate the door further, right? Same as compared to 2 and 1. At 4, there is no motion of the door only. Yes, at fourth point, it will move.
No, sir.
Okay. So what I did here, the force is remains same, but the rotation is different at different points. It is not same. At first point, it is more. Now consider the second one. Second case. The second case is, see. So I'm not applying the force always perpendicular. Perpendicular ಆಗಿ apply ಮಾಡ್ತಿಲ್ಲ force. So one time perpendicular, ಇನ್ನೊಂದು time so ಈ ತರ ಡೋರ್ಗೆ, ಸೊ ಸೇಮ್ ಡೋರ್ ಅಂದ್ರೆ ಹಿಂಗಿರುತ್ತಲ್ಲ, ಸೊ ಇದೇ ಕಡೆ ನಾನು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಡೋರ್ ಯಾವ ಕಡೆ ಇರುತ್ತೋ ಅದೇ ಕಡೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಅರ್ಥ ಆಗ್ತಾ ಅಂತ ಹೇಳ್ತಿರೋದು?
Yes,
Guys.
sir.
Towards right side, sir.
ವಿಡಿಯೋ ಕಾಣ್ತಾ ಇದ್ದ?
Yes, sir.
ವಿಡಿಯೋ ಕಾಣ್ತಾ ಇತ್ತಲ್ಲ? ರೈಟ್, ಸಿ ಇದು ಡೋರ್ ಅಂತ ಕವನ. ಸೊ ಇದು ಡೋರ್ ಅಂತ ಕವನಿಗೆ, ಇದು ಇಂಜಸ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಇಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ಇವಾಗ ಫೋರ್ಸು ಈ ಡೈರೆಕ್ಷನ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ, ಎಕ್ಸಾಕ್ಟ್ ಹಿಂಗೆ ಸ್ಟ್ರೈಟ್ ಆಗಿ. ನೆಕ್ಸ್ಟ್ ಸೊ ವಿಲ್ ಅಪ್ಲೈ ದ ಫೋರ್ಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ಹಿಂಗೆ. ನೆಕ್ಸ್ಟ್ ಐ ಆಮ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಫೋರ್ಸ್ ಲೈಕ್ ದಿಸ್. See, this is perpendicular exactly. So these hinges is fixed and this is perpendicular. Now if you apply the force like this, so not perpendicular, it is somewhat like this, like this, like this, like this. So ಏನಾಗ್ತದೆ ಅವಾಗ? What will happen? Is the door is moving, rotating with us?
No, sir. Perpendicular.
Is the door is rotating? No. Right? So So okay, only one perpendicular force if you apply, the door is rotating is with more rotation. Yes or no?
Yes, sir.
Yes, sir.
Force in a same point. Point will be same only. At the same point we are considering. At the same apply the force perpendicular, different directions. Then, if you apply the force perpendicular, then the door is rotating with high rotation. So here, two things we have observed. One is same force, but the distance is changed. Yes or no? First case. This is 1, 2, 3, 4. Distance is changed. Second one, distance is same. Force direction is changed. Force direction means what? Theta is changed. Theta is what? Angle between the position vector, that is R, this R,
Door and hinges.
and this is the force F. Clear? So here we fixed the door here, and the one end to other end is this one, the distance is R, and here we are applying the force perpendicular force we are applying. And that case the torque will be maximum, that is called as torque. Rotating force is called as torque. The rotating force is called torque. ಅಂದ್ರೆ ಸೊ ನೀನು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನೋದು ರೋಟೇಟ್ ಆದ್ರೆ ಆ ರೋಟೇಟಿಂಗ್ ಫೋರ್ಸ್ ನ ಏನಂತೀವಿ ನಾವು ಟಾರ್ಕ್ ಅಂತೀವಿ. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
So that rotating force is called torque, and also called movement of force. We also called torque is also called as a movement of force. ಅಂದ್ರು ಒಂದೇ, torque ಅಂದ್ರು ಒಂದೇ. So now we have to write the torque equation. So torque, if you write the torque equation, what is torque? So one thing clear, that is the torque is depends on, that is rotation is depends on, so this distance as well as the angle between the force and R value, na? Yes,
Yes, sir.
sure. So therefore torque tau equals to R cross F, RF. So one thing we discussed, when is the maximum torque will be, means maximum rotation will be there
Perpendicular.
when you means
Sir,
when R
90.
is maximum.
Yes.
Yes or no? When R is maximum, and if you apply the force perpendicular to this one, na?
Yes,
Yes.
sir.
That is when you leave torque
Yes,
tau
sir.
equals, so since the torque tau is also a torque, this is, we call it as tau, TYU, tau. So tau, the symbol is tau. R cross F, just before discuss, that is RF
Sin theta.
sin theta, na?
Yes.
RF sin
Yes.
theta into n cap. And just before we told, when theta is 90, then torque tau equals to what?
Maximum.
RF
Yes, sir.
maximum. So when theta is 90, RF. So this is the maximum torque will apply. So now we can write, this is explanation of the torque. Did you understand what is torque? Torque is the rotating. And what are the SI units, pa? So SI units.
Newton into meter.
SI. Newton meters of the SI units of torque.
Sir,
So use S.
dimensions of torque is equal to energies, no? Energy.
Dimensions of torque is equal to energy only. That is work done, W equals Newton meter.
Yes, sir.
So F into S. F is Newton, S is meter. So Newton meter. That is dimensions of energy. Energy is nothing but dimensions of torque. ml square t power minus 2. So dimensions, if you write dimensions of torque, ml square t power minus 2. Okay. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
Yes, sir. And frequency and engagement is similar, no, sir?
No.
It is like frequency is like,
F.
yeah.
Angular frequency and angular velocity is same. Angular frequency.
Yes,
Okay.
sir. Okay.
So So torque, we can also write a torque tau equals to RF sin theta. We can also write like this. So we can write F into R sin theta. Okay, na?
Yes.
Yes, sir.
And usually we can write force into perpendicular distance. We'll write force into perpendicular distance. Force into perpendicular distance we'll write. So this is the torque, or we also call it as moment of force. అర్థమైందా?
Yes,
Yes,
sir.
sir.
How to direction of the torque means again by using the right hand thumb rule. Right hand thumb rule. So now see here. So keep your 4 fingers in the direction of R like this. In this direction. So and if you bend your fingers downside, then what about the thumb? Thumb in which direction it is indicates? Thumb. Which direction indicates? Right hand ingidre. So ingittu, then you keep the fingers downside. Then force will be indicates
Left.
left, no? For you, yes?
Yes, sir.
That is a torque. Understood?
Yes, sir.
Torque,
So usually-
torque will be always along the axis of rotation, no?
Yes.
And angular velocity also.
No, not along the axis of rotation. So it is along z axis. So if we consider in rotation motion, if see now our 4 fingers I will keep in this direction like this. This is a position vector R, and we are applying the force in this direction F. Then what about torque? Torque will be outside.
Yes, sir.
So that is nothing but a positive z axis. So if anti-clockwise rotation, if anti-clockwise, then torque will be positive. And if it is clockwise,
Negative.
Negative.
torque is negative z axis. Understood?
Yes.
Sir, if the rotation is happening in xz plane, then torque will be in y-axis, no, along y-axis.
Xz along y axis.
And along y-axis, axis of rotation will also be there now. That is why, yes, sir. Like torque will always be axis of rotation now.
Okay. Fine. So next one, linear momentum undali, angular momentum undali, that we can discuss in the next class.
Thank you,
Can I-
sir.
Okay, bye.
Thank
Bad
you,
lens,
sir.
sir.
Bye.
Thank you, sir.
Thank you. Okay. Had.
Bye, sir. Bye, sir.
Bye.